lesson 6.8 is graphing radical functions. And I know some of you have already looked at this and already started to stress because it is graphs. Okay? I will tell you, I personally think as graphing goes, this is on the easier end of graphing. Okay? You have to give me a chance to explain it and everything. But this graphing is on the easier end of the graphing that we've done. Definitely easier than parabolas. Okay? We're going to, first semester, how we took graphs and we did a lot of shifting things left, right, up, and down. That's basically what we're going to do. We're going to learn the shape of a square root graph and then a cube root graph, and we're going to move them. So try and make it as easy as I can on you. Now, I know you guys will have to graph them in Math Excel, which makes it a little bit more difficult, and sometimes that is just multiple choice, which one matches, but okay, up top here. So talking a little bit about the parent function. So the parent function being, okay, what graph is this we're moving? And on the front page, we're just going to be talking about your basic square root of x graph. You'll notice on the front page, all of these graphs that we're going to look at have a square root of x in them. So we're going to look at that square root of x. On the back page, we do have a couple cube root graphs we're going to do, but the nth root of x could represent anything. Remember a negative. This was one, I think we had this on our gold paper first semester. A negative will take something and reflect it. And so you won't see negative, we won't really have to worry, at least not too much, about negatives inside the radical. They're usually more outside. But a negative outside the radical, so a negative out front, is going to take your graph and reflect it over the x-axis. So did not catch that. Okay, so when we talk about reflecting over the x-axis, we're talking about taking it up top and maybe flipping it down low, or vice versa. Okay, again, think back to that gold paper. If you think back, a number out front, so an A value, and I think we used A value on the gold paper if I recall, but an A value would represent either, here it says stretch or shrink. As I just pulled the gold paper out, it says stretch or compression, right? Okay, so that represents a stretch or shrink. If A is bigger than 1, it's going to stretch it. If A is smaller than 1, it's going to shrink it or compress it. And that is if you're multiplying by a value out front. It's a vertical stretch or shrink. And then the ones we're most familiar with that are the easiest to work with are these horizontal and vertical translations. So taking a graph and moving it left and right or up and down. Now, if you can think back to the gold paper and how things worked, H and K, one of those is under the radical. H is under the radical. K is outside the radical. Which one is our horizontal left-right movement? Which one is our vertical movement, up-down movement? Do you remember? Or can you, based on what we learned first semester, can you guess? What do you think, Justin?
H is left and right, K is up and down.
Okay, and why do you think H is left and right?
Because it's high, from what I remember, H was here.
Okay. Remember the whatever's added or subtracted inside the parentheses, inside the absolute value. Right there with the x is your left or right. And so that H right there is your, if I want to get fancy, I'm going to say the horizontal. But if you don't like the word horizontal, it is exactly that, left, right. Now, take a guess here. Since it says x minus h, what was true when we were moving left and right first semester? Opposite the sign. Same thing, guys. It's x minus the value under the radical. So it's going to be left or right opposite the sign. Okay? What about the plus k? That, of course, then, that's the one that's at the end. It's not with the x, and so that is our up and down. That is our vertical movement, or in other words, up, down. And that one, you are going the direction of the sign. This ties into what we learned, didn't it? Okay. Well, I'm ready to start into example A when you are. What are the graphs of each of the following? So, A, we're going to start very basic, because in order to graph any of these square root of x ones, you kind of need to know what does y equals square root of x look like. Do you know what the square root of x graph looks like? Somewhat. Depends what it's doing after it goes through that point. Okay. And here's what I'm going to say. If you don't know what it looks like, what am I going to suggest we try? What? Plug in values. Let's come. If you don't know what a graph looks like, I'm always going to say, okay, let's try an XY chart. Okay, we have to be logical about our x values we pick. What are some good x values we should pick?
0, 1, 2, 0.
Okay, I'm going to take these on individual basis. I like 0. Definitely like 0. 0, it's very rare you'll see me not use 0. And when we plug in 0, what are we doing? We're plugging 0 in right there, yes? And for x, what is the square root of 0? 0, yes? Your calculator would agree too. If you don't believe me, try your calculator. Square root of 0 is 0. Okay, next I heard 1. I definitely like 1. Only my second favorite after 0 usually. So if we put 1 in for x, what is the square root of 1? 1. Okay. 2. Okay. You can put 2 if you want here. Notice I haven't written it down yet because when I put 2 into the square root, I get a decimal. And my calculator can give me that decimal. However, do you want to graph 1.414? No, that'd be kind of silly. Okay, so we don't like 2. We're going to skip 2. Normally I don't skip 2, but for square roots we're skipping 2. I heard Emma say 4. Why did she skip 3? Yeah. Square root of 3 is a decimal again. But when we get to 4, what do you know about 4? Square root of 4 is 2. If I ask you for one more number, what would be the next x value after 0, 1, 4? 9? What is the square root of 9? 3. You can use any number in between, but we're going to give you decimals, and no one wants to graph decimals, your teacher included. Now, what about negatives? Should I use negatives?
I say no, because that sounds like a
Okay. What happens when you do the square root of a negative on your calculator?
bad thing.
Can you do the square root of a negative value? No, because the square root means what number times itself. And there is no such thing for a negative value, because in order to get a negative, you have to do a positive times a negative. So you won't ever see as the graph does not exist in the negative values. Okay, so go ahead and graph this. 0, 0 is at the origin. 1, 1 means we go right 1, up 1. Remember, in an ordered pair, it's always left or right, then up or down. 4, 2. Right 4, up 2. And 9, 3. Right 9, up 3. Your 4 dots look kind of like mine?
Yeah.
Is it a line?
No.
No, it's not a line. And it shouldn't be a line. If you're getting a line, then you did something wrong. Okay, it is a curve. It starts at 0, 0, so do not draw an arrow on the other side of 0, 0. And it continues out past 9, 3. So beware of that. 0, 0 is a starting point. No arrow, because there's nothing past 0, 0. There is an arrow over on the right, though. What shape does that look like?
Half a parabola.
Half a parabola? Half a U? Half a sideways parabola? And that is exactly what it is. It is the positive half of a parabola because square root of x is the inverse of x squared. Remember how we were finding inverses last week, switching x's and y's? Well, that's the thing. This is the inverse of x squared. So parabola, square root. Okay, we good with A?
Sure.
That wasn't too bad. Now, here's what I'm going to tell you. Memorize this shape. I would even recommend be very familiar / memorize these ordered pairs. Because, and different people do this different ways, but based on how I teach. Okay, what are your thoughts on B? Y equals square root of x minus 2. Could do an XY chart.
Or you could take the same thing and just subtract 2. Yeah, or move it over. Or like move it down 2.
That was a process. I was just letting them kind of reason it out back there. Okay, so here's my thing. You can set up an XY chart there. I'm not going to say you can't. Okay? And because this one is an up-down movement, an XY chart would still work relatively easily. However, my recommendation is I'm going to use the same XY chart from before and just move these values. What is this minus 2 telling me to do? It tells me to move my graph down 2. We're going to translate the graph down 2 because the minus 2 is outside of the radical, so it takes it up or down the direction of the sun. Now, two different ways to do this. One option, could you go ahead and graph these original 4 dots and then just move them down 2?
Yeah.
You can. So you could go ahead and graph 0, 0, 1, 1, 4, 2, and 9, 3. And then what do you do with each of those 4 dots? Move them down 2. So 0, 0, I'm going to move it 0, negative 2. 1, 1, I'm going to move it down 2. 1, negative 1. 4, 2, when I move it down 2. 4, 0. And 9, 3, when I move it down 2. 9, 1. Did you have to graph the original dots? No, you didn't have to. More power to you if you want to. I don't care. Okay. And then I'm going to connect my dots, remember? Okay, that kind of, well, I didn't do the best job on connecting my dots there, but you get the idea, right? Notice I started at 0, negative 2, and I have an arrow on the other end. As I promised, it's not horrible, right? The basics are pretty easy. I'm also, are you realizing that once you graph this graph enough times, it's going to be kind of ingrained in your head what the shape is? Okay. What about C? Move them all where? Okay. Plus 1 outside of the radical is up or down. Because it's a plus 1, I'm going to take each of my dots and move them up 1. Again, it's your comfort level. Do you want to put the original 4 dots on there? If so, 0, 0, 1, 1, 4, 2, 9, 3. Obviously, on Math Excel, can you put the 4 original dots? Can you put the dots on there?
You
Honestly,
can.
okay. Honestly, I don't even know if they have you graphing these or if they have you just doing multiple choice. It might be more multiple choice, honestly. I just don't remember. Okay, so take each of those points and move them up 1. So 0, 0 goes up 1 to 0, 1. 1, 1 goes up 1 to 1, 2. 4, 2 becomes 4, 3. 9, 3 becomes 9, 4. Okay. If you are not really caring for how I teach, then, and you'd rather make a new XY chart every time and find those values, you can do that. It works okay on these up-down movements. Bottom 2. Y equals square root of x plus 2. What's different on this example A down here?
The plus 2 is inside the radical.
Plus 2 is inside the radical. Does that change anything?
It just changed the direction.
Yeah, if that plus 2 is under the radical, remember, under the radical is going to take us
Left to right.
left or right. That's our h value. So, what does this plus 2 under the radical tell me to do? Okay, we're going to go left or right 2, opposite the sign. So, positive 2, you kind of think right 2, but you actually need to go left 2. Now, do you guys need me to put, do you remember your XY values from above? Well, that might be a valid question. Do you remember your left and right? Is it which hand makes an L?
I've seen Kylie do the hand trick sometimes.
So,
There is no shame in it, okay?
I'm not
I'm
going to
not
blame
shaming
you.
her. I'm just saying I've seen her do it.
You know, if I see a left-right hand trick on the quiz or a test, here's the deal. Did you at least get it right? I
I
mean,
got it right.
so that's all that matters, right? Okay, so left 2. Now, again, do you want to put your original dots? That's up to you, yes? If you put your original dots, again, they were at 0, 0, 1, 1, 4, 2, and 9, 3.
Just in case. Precautionary measures.
Now, left 2, 0, 0 is no longer at 0, 0. It needs to go negative 2, 0. 1, 1 becomes negative 1, positive 1. 4, 2 backs up 2, so it's at 2, 2. And 9, 3 backs up 2 to be at 7, 3. Again, that first dot that was at 0, 0, it is a starting point. Do not put an arrow on the other end of it because I will count off come test time. Okay? Now, this is the one where I do not encourage you to do a new XY chart. This is why I teach them all as translations, left, right, up, down. Because if I take 0 in here and I put in 0, 0 plus 2 is 2, and now I'm doing the square root of 2. Wasn't that what we were trying to avoid earlier?
Yeah.
It was. So if you want to do an XY chart, you essentially have to subtract 2 off of all this 0, 1, 4, 9 to make it work. So this is why I teach take your original values and translate. Okay, you guys got B under control? Y equals square root of x minus 3. What are we doing?
Right.
Because the minus 3 is under the radical, it's left or right. Because it's a minus 3, we're going to go right 3. You have your original dots memorized at this point? This is your 5th graph using them, right? Original dots are 0, 0, 1, 1, 4, 2, 9, 3. And again, if you forget those dots, are you just stuck and can't do anything? No, if you forget those dots, go recreate your original XY chart. Just do the square root of X to recreate that if you forget that. Okay, I'm taking each of these dots and going where? Right 3. So 0, 0 becomes 3, 0. 1, 1 becomes 4, 1. 4, 2 becomes 7, 2. And 9, 3, 12, 3. On a situation like that, I tend to go ahead and put the dot on there. Does that look like it's about in the right spot if I kept counting correctly? That's what I try and do. I mean, I can see where 10 would be. I don't know, maybe I need to scoot over a little bit more, but you get the idea. Notice again, starting point on the left, arrow on the right. Hunter. I've lost Hunter, haven't I? At one point, you know, at least,
Give him the 1 point.
you know, at least he's honest. At one point, he was with me at the beginning. I don't know where I lost him, but okay. Okay, guys. Example 3. What happened as we changed the page?
Now we're translating in this.
Up and down and left and right.
Okay, so we went from the front side, where we had one little translation, to the back side, where now, if you look closely, we've got to go a left or right, an up or down possibly. There's a negative, which means a reflection, and there's that A value, which means a shrink or a stretch. So all of a sudden we went from 1 to like
3, 2,
everything, 3 or 4 of them. Okay, so first thing I want to do, let's dissect this. It's not science, but we're going to dissect this, okay?
Okay.
Pick a piece on this example A, and what does this piece mean? What does it tell me to do to the graph? Okay, it's going to shrink. Shrink by a factor of?
Oh, and it's going to reflect in the x-axis.
Okay. So for the 1/2, I'm going to say that is a vertical shrink. Notice I just circled the 1/2. So the positive value 1/2 tells me to shrink by 1/2. So our y values are going to shrink in half. Okay, I'll help you with that. What's that negative do? The negative is a reflection. So you need to think about those as kind of two different things. Officially, it is a reflection in the x-axis. Now, I'll be honest, there's a couple different ways I can show you how to deal with those. As I show you, I'm going to kind of use them hand in hand and deal with those both together. What are the 3 and the 1 telling me?
Three telling you to go right, 3, the 1 telling you to go.
Okay. The -3 under the square root, under the radical, is left or right, opposite sign. So we are going to go right 3. The +1 at the end is up or down direction of the sign, so we're going to go up 1. This is a challenge of the day, okay? I'll be honest. These are the hard ones of the day because you've got a lot going on, but it's very doable. Now, my recommendation, making sure I'm, okay, is that we first worry about the reflection and the shrink, and get new ordered pairs for those, and then we'll take those ordered pairs and go left or right and up or down. So in other words, in this case, the right 3, up 1. So I'm going to have us, let's see, how do I, first of all, that is a little longer than I wanted it. What was our original, this is a square root graph still, yes?
Yes.
No matter what happens, it's a square root graph. What were my original ordered pairs for a square root graph?
0, 0, 1, 1, 4, 2, 9,
0, 0, 1, 1, 4, 2, 9, 3. Those came from the front of my notes, yes?
Yes.
We already did those together back on our original example A today. Now, what do we need to do, excuse me, to represent our reflection and our shrink? Well, we're going to shrink by 1/2, and we're going to reflect, which can be also multiplying by a negative. So what I suggest we do is we take each of these y values and multiply them by this right here. So I'm going to suggest that we take each of our y values and multiply by negative 1/2. We're going to write out the results here. But because it's a vertical shrink, y values are vertical, so they only ever affect the y's. We're going to multiply those by negative 1/2. Now my x values will not change. So we're going to take our y values and multiply by negative 1/2. So my first y value was 0. What is 0 times negative 1/2?
0.
0 times anything is 0. So that's my new y value. Okay, we have a y value of 1. What is 1 times negative 1/2?
negative.
When you multiply 1 times something, it stays what it is. So negative 1/2. The next y value of 2. What is 2 times negative 1/2? What's half of 2?
Negative.
Half of 2 is 1. Positive times negative makes it negative 1. Negative half times 3. What's half of 3?
1.5.
What'd you say?
3 over 2.
1.5.
1.5, 3 over 2, 1.5. And I'm going to say negative 1.5 just because we're graphing it, but negative 1.5, negative 3/2. I'm good with any of those. Okay, guys, here's what we're going to do. We're going to take, these are our new and improved y values. We didn't do anything with the x's, so guess what? We're going to use our original x's. So we're going to graph our original x's with our new and improved y's. And then we're going to move these points. Where do we have to move these points? Right 3, up 1. So we're going to graph these. I'm just writing myself a note down here so you see. Graph. And then, once you graph those, then move. What was it? Right 3. Up 1. We're going to graph those x and y's, and then we're going to move them the right 3, up 1. Give you a moment to write that, and then I'll take you through the graph. You ready? So I'm graphing what I have up there in red. So first of all, instead of 0, 0, I'm graphing 0, 0. Okay, that one didn't change because it just stayed the same. Instead of 1, 1, I'm now going to graph 1, negative 1/2. So that means I'm going to go right 1 and down 1/2. Not the easiest, but you can cope. Instead of 4, 2, I'm now going to graph 4, negative 1. So right 4, down 1. Instead of 9, 3, I'm going to graph 9, negative 1.5. So I'm going to go right 9 and down negative 1.5. Now, what have we done at this point?
Mean the other side.
Okay. We made the other side the parabola, which means we have taken this and we have reflected it. And is it a smaller half of a parabola? We've shrunk it, haven't we? We've pulled it closer into the x-axis. So what we've done with that negative 1/2, we've done our reflect and our shrink. What do I still have to do? Graphed those, and now move right 3 up 1. So take each of those points you just graphed and move them right 3 up 1. So 0, 0. I'm going to go right 3 up 1. So it's at 3, 1. 1, negative 1/2. So I'm going to go right 3. And then I'm going to go up 1. So I went right 3 to 4. When I go up 1, I end up at positive 1/2 instead of negative 1/2. Okay. I had 4, negative 1. I'm going to go right 3, which puts me at 7. I'm going to go up 1, which puts me at 7, 0, I believe. And then 9, negative 1.5. So right 3 puts me at 12. And then up 1 puts me at negative 1/2. So I end up being at 12, negative 1/2. In mine, it's right next to my 9. I don't know where yours ended up. And now, I don't like how I did that. Okay, looks something like that. My point 3, 1 is an end point. I have an arrow on that right side. How are we feeling? As I said, that's the tough one. I think it's doable still, but it's tough. I get it. Okay. Where are we at on time? Okay. B. We don't have time to get all the way through this. I know that. But can you at least identify the pieces? Identify the pieces with me. I'm hearing the easy pieces. The +2 under the radical is left to right opposite the sign. Since it's +2, we know we have to go left 2. The -4 is at the end. So that's up or down direction of the sign. So we're going to go down 4. I don't know if I heard anyone else say the other one. I think you guys all got quiet on the other one.
Stretch of 3.
Stretch of 3. Officially, because I like to be specific here, I am going to say it's a vertical stretch of 3. So we're going to talk vertical stretch of 3 there. What I'm going to encourage us to do is to multiply to get our stretch of 3, and then we'll move those points left 2, down 4. So when we come in tomorrow, we will be working with, what was our original XY ordered pairs?
0, 0, 1, 1, 4, 2, 9, 8.
Okay, so I at least have one person that has them memorized, right? 0, 0, 1, 1, 4, 2, 9, 3. So we'll take those values, we'll multiply for our stretch of 3, and then we will move them. And you can go ahead and work on that right now. But then we'll, as a class, we'll have to complete it tomorrow. Okay? Got it? Okay.
Do you multiply whatever you like vertical